Welcome to aminacademy.com. In IB Diploma Mathematics, let us discuss about 3D vectors in component form. Look at this here, XY plane is given. In that, a point P is in space of the point with X, Y, Z. Now, the X, Y and Z steps from the origin to P are x1, x2, x3 like here from origin to P it gets the values of x1, y1, z1. Now suppose y is origin 0, 0, 0 and P suppose x1, y1, z1, then vector OP is equal x1 minus 0 is x1, y1 minus 0 is y1, z1 minus 0 is z1. So it is a vector OP. Now, in the space, there are 2 points. Let point A equal x1, y1, z1 and B. B is with point x2, y2, z2. Then vector AB can be represented in vector form like x2 minus x1, y2 minus y1, z2 minus z2. This is a vector in component form. Here the magnitude of the vector. Magnitude of vector in space. If vector A equal A1, A2, A3, then magnitude of vector A is nothing but the square root of A1 square plus A2 square plus A3 square. Next, equality of vector. If two vectors are said to be equal if they have the same magnitude and directions. Suppose, look at here, two vectors. We'll draw two vectors in space. We draw. Here, these two vectors are said to be equal because its magnitude and direction is same. Magnitude and direction. Direction is same. Then you can see if vector A is represented by A1, A2, A3, then B vector is B1, B2, B3. Then you can say if vector A equal vector B, then you can say A1 equal A2, B1 equal B2 and C1 equal C2 as well, that magnitude of vector A is equal to magnitude of vector B. Now you can understand if two vector is said to be equal vectors, equality of vectors, then you can see its magnitude and direction is same. But here, so these two vectors are parallel as well. Parallel as well, the magnitudes are equal. Here, suppose some points are given. Vector A equal 5, 3, minus 2. Vector B equal 4, 0, 2. Then find OA. Vector OA is, that is vector OA. Vector OA means just start with origin. So OA is 5 minus 0, 3 minus 0 and minus 2 minus 0. Therefore it itself 5, 3 minus 2. Then vector AB is B minus A. So this vector also written as 5, 3, 2. 402, we can write this 402 in this one. Five, 3, 2. Then AB is B minus A, that is 0 minus AB minus B minus A, that is 3 minus 5 is minus 2, 0 minus 3 is minus 3 and 2 minus 2 is 0. Like this we can find OA, AB, BA, anything can find regarding the positions. Now one more example. If A is minus 2, 3 and 2, B equal 2, 1 and minus 4. We have to find the position vector of A from B. The position vector of A from B. A from B means from B to A you have to calculate. That is A from B means nothing but B minus BA. That is vector AB is equal B minus A. 2 minus of minus 2, 1 minus 3 and minus 4 minus 2. This is a which is equal 4 because 2 minus 2 is 2 plus 2 minus 2 minus 6. Now one more example. This is a parallelogram. In this A is given minus 1, 2, 1. B is 2, 0, minus 1. C equal A, B, C. and D is equal to 3, 1, 4. Here in parallelogram, 3 points are given, that is A, B and D. Fourth point we have to let it is A, B, C. In this, we have to find coordinate of C. How to find coordinate of C? In this, here DC, the vector DC, if this is a parallelogram, opposite sides are equal as well as the directions are same. So vector AB is equal to vector DC. Vector DC is equal to vector AB because of its parallelogram, opposite sides are equal as well as the direction is same. So equal vectors. In this DC, vector DC is A C minus D, A minus 3, B minus 1 and C minus 4, which is equal AB is B minus A, that is 2 minus of minus 1 and 0 minus 2 and minus 1 of minus 1, minus 1. Here simplify, 2 plus 1 is 3, minus 2, 0 minus 2 is minus 2 and 0 because minus 1 of and plus 1. So here A minus 3 is 3, equating this and this. A minus 3 equal 3, which gives A equal 6. B minus 1 equal B minus 1 equal to minus 2, which gives B equal minus 2 plus 1 is minus 1. And C equal C minus 4 equal 0, which gives C equal to 4. Therefore, we have to find the coordinate of C. Therefore, C is ABC, there, B, C equal 6 minus 1, 4. Then also you can find midpoint of, suppose you can find midpoint of the length dB, midpoint of dB. Suppose we have to get the midpoint of dB, which is nothing but midpoint is addition of these coordinate points divided by 2. That is 2 plus 3 by 2 dB. That is 2 plus 3 by 2. 0 minus 1, 0 plus 1 by 2. And as well the last point, minus 1 plus 4 divided by 2. Minus 1 plus 4 by 2. Or given as 5 over 2, 1 over 2, 3 over 2. Therefore, coordinate of the midpoint dB. Now, how to find length of dB? length of dB means the square root of, first we have to find that now. dB is 3 minus 2 the square, 1 minus 0 the square, 4 minus 1 is plus 1 square, which is equal 3 minus 2 is 1, 1 square, 5 square, which is equal square root of 1 plus 1 plus 25, square root of 27 is the length of AB. So far we discussed vectors in three-dimensional space, position vector as well component of the vectors. I have done. Please subscribe our YouTube channel.